Are you able to see my full screen slide?
Not yet. Yep.
All right. Greetings, everyone. Welcome to Exchanging Ideas Session 15, Global 5G Evolution. Kindly take a second to click subscribe button on this YouTube channel. A big and warm welcome to great speakers around the world to present the latest 5G development. So I'll start first with this presentation titled the 5G Private Network Transforming Enterprise and Industry. Now, today, the large enterprises, businesses are increasing in need of a dedicated, reliable mobile private network to address their complex requirements. A mobile private network requires resilience, quality of service, mobility, security, and integration with business applications. And the IoT and human communications across the facilities are targeted use cases for improving productivity, reducing costs, and improving customer experience. And AWS has worked with global telecommunications APN partners and create a set of cost-effective hybrid model private network solutions with carrier-grade core virtual network functions like cloud network functions, OSS, BSS, and business applications hosted both in the cloud as well as on the premises. As you can see on this particular slide, the AWS cloud with the point of presence of local zone, where AWS has offered AWS wavelength on the public mobile infrastructure, and also the AWS outpost that is being offered to the on-premises facility. And then we have this AWS snowball on the edge for a larger scale of enterprise users. And there is a AWS snowcon for the smaller scale of enterprise customers. And there's a AWS IoT Greengrass and AWS IoT Sidewise, and also the machine learning, where it's been offered towards at the edge in the using the Sage Maker. Now, this is quite an interesting slide where very much involved in terms of the AWS Edge and IoT capabilities, right? And in this architecture, we have this AWS IoT services, including the AWS IoT Core, Amazon Free RTOS, right? And AWS IoT Greengrass offer a complete suite of connecting, controlling, and managing the IoT devices from the cloud or the edge. And this is further enriched by the AWS IoT analytics and machine learning services, and what they call extract the value of the IoT and drive the decision making, right? So enterprise sites vary based on the business requirement, be it what we say, it can be industrial plant or mining sites, or also when it comes to the campuses or other edge locations, right? So what we can see here is that it has this AWS cloud with the virtual private cloud with the AWS machine learning and AWS IoT. All right, and AWS provides the edge infrastructure and software that moves data processing and analytics as close as necessary to where data is created in order to deliver intelligent real-time responsiveness and to streamline the amount of data that is transferred. And this is quite an interesting slide with the mobile private network with the AWS outpost, right? So the AWS outpost is the underlying infrastructure for the mobile core, user plane, and control plane, as well as business applications such as the machine learning, industrial IoT, and communication applications. So the core control plane, subscriber provisioning, policy, and management functions are hosted in the AWS region inside a virtual private cloud. The other part is the mobile private network with AWS Snowcon. And AWS Snowcon, as I mentioned earlier, is very much focused into the enterprise, small scale industries, where AWS Snowcon is the underlying infrastructure for the mobile core user plane. You can also use the AWS Snowcon for small scale disconnected remote site network as well. The other one is the mobile private network with AWS Snowball. And AWS Snowball is for a large scale connected remote site network. And in terms of the AWS region, it still facilitates the control, policy, and management functionality, and the subscriber provisioning and mobile core and the control plane are also part of the AWS region deployment. And this AWS Snowball also can be applied for the disconnected remote site network, where it does not require the connectivity from the edge locations to the AWS cloud. Now, I would like to spend a bit more time in this particular slide. If you see on the top part, where this is the traditional, where old the mobile network operators, which how they deploy the cell sites of the RU, and in terms of the edge cloud sites with the DU and the CU and the UPF, plus the mobile network operator central cloud, right, where the functionality of the PCF, UDM, AMF. But when it comes to the disruptive way of how the cloud native has been deployed in Rakuten, which is the Japan's fourth largest mobile operator, they have actually deployed the COT server, right, towards to the edge cloud. And Rakuten's network, it's designed to ensure the company's edge computing facilities are physically close enough to each of Rakuten's radio to control them without the potential debilitating the lag that would be caused by a more centrally controlled system. And the edge computing application is controlling its radios, and the edge computing network are used to handle the content delivery chores of its Rakuten streaming TV services in Japan, right? Because that is one of the main content that they have been focused on. And Rakuten started with content delivery network application. They also have involved with the IoT type applications, augmented reality, virtual reality. They may begin opening network to enterprises and other developers to explore additional edge computing applications and distributing low latency contents to the user. And Rakuten has about 3,000 edge data centers, and they have about 57 bigger regional data centers, and also 3 big central data centers. Now, lastly, what I would like to explain here is that compared to Rakuten, Dish Wireless Network, they have actually worked, or they made a deal with the AWS in terms of deploying the edge in the local zone and also in the AWS region, right? And Dish have actually deployed the RAN hardware from Fujitsu and the RAN software from the Altio Star and Mavenir, right? And but the one thing of Dish Wireless, if you compare to Rakuten, because they are geographically a quite huge network, and they may need to deploy more number of edge boxes throughout the closer to the customer sites or the enterprise sites. And the advantage of deploying such, where in terms of the capex reduction is less expensive than buying the COT server and developing the virtualization platform. And in terms of the OPEX reduction, by scaling up down AWS computing resources according to traffic conditions, and the monthly fees are reduced, thereby reducing the OPEX. In terms of the cloud advantages, scale up, down, analytics, machine learnings, and AI services are being deployed over here. And lastly, this would be my last slide. What I'm trying to say here is that like Dish, though they came late, right, as the fourth wireless operator in the US market, and when they had done this deal with hyperscaler Amazon Web Services, and they have actually recently announced plans, right, to work together, where Dish will leverage the AWS infrastructure and services to build a cloud-based 5G open radio access network. And this is the first 5G radio hyperscaler deal. And Dish is exercising an option to run the ORAN using the AWS Graviton hardware plus the enterprise Kubernetes services. And additionally, Dish has an option to use the Intel-based CORDS-based hardware in parts of its network. So the RAN DU function will be running on an AWS outpost, and in particular a 1U version that it gives a and they use the in-house ARM-based developed Graviton 2 processors, and that's how they will deploy in the industry for the 5G private network. So due to the 10 minutes time gone, this is my presentation, and I would like to move on to the pass on to the next speaker. Let me introduce Florian. Is Florian on board? No. Okay. Then next, let's move on to the next speaker, Uttara Sawan, to present from Plano, Texas, USA, to present on the 5G network integration with non-terrestrial networks.
All right. Thank you. Imagine being stuck on a remote cruise ship, hundreds of kilometers in deep ocean, or unfortunately in middle of a natural disaster, or on a remote oil rig and platform. Can we ensure service continuity and connectivity in such extreme conditions? How can we improve secondary or backup connections? 5G solutions are adapted to combine terrestrial and non-terrestrial components to support such use cases. Hi, my name is Uttara Sawant, and today I'll be taking you through 5G's literally out of the world non-terrestrial concept, which is 5G NTN. This is the agenda for today's presentation. According to 3GPP Technical Report 38.811, non-terrestrial networks are networks or segment of networks that include the airborne or spaceborne vehicle to embark, transmission relay node, or base station. They also include satellite communication networks, that is low Earth orbiting, medium Earth orbiting, and geosynchronous Earth orbiting satellites, high altitude platform systems, including the airplane, airship, or balloons, air to ground networks. These are used to provide in-flight connectivity in airplanes. Due to the NR forward compatibility, NR has been expanded to support NTN scenarios, leading to 3GPP's NR NTN work item. For release 17, the LTE-M and NB-IoT is been expanded to include the NTN scenarios. The 3GPP technical report also includes numerous use cases to support NTN scenarios, along with the corresponding satellite type for each use case. And this is depicted in this particular table. Why should you care about this? Okay. The role of NTN in the development of 5G networks is evident in following verticals: transport, public safety, media, entertainment, e-health, agriculture, finance, and automotive. So thanks to this widespread coverage and the reduced vulnerability of spaceborne vehicles to physical attacks and natural disasters, NTN is in a strong position to foster the rollout of 5G services to unserved and underserved areas. Second, to reinforce the 5G service reliability to provide service connectivity, and finally, to enable 5G network serviceability for in terms of broadcast, multicast, and backhaul services. This figure shows the NTN architecture. The 5G core is connected to the G-Node B through the NG interface. G-Node B is connected to the NTN gateway, and that via the feeder link is connected to the NTN payload, which is a network node on board the satellite system. NTN payload is connected to the NTN terminal, that is user equipment, to the service link via the UU interface. Now, based on this principle, there are possible combinations of satellite and aerial access architecture. And these combinations are shown on this particular slide as well. Let's move on to the interesting topic, standardization requirements. So from left to right, we will start with RAN. Now, the goal of release 15, well, part of goal of release 15 was to identify scenarios and channel models for NTN scenarios, as well as this was extended as a follow-up item in release 16 to identify and recommend the solutions. For user plane, the main concern is really the long propagation delays. The impact of delay on medium access control, radio link control, packet data convergence protocol, and service data adaptation protocol is also studied. For control plane, mobility management procedures are examined. HARQ processes are expanded from 16 to 32 to address the long delays. Services and system aspects. For the satellite access scenarios, use cases include the use of satellites for broadcast services. For satellite backhaul scenarios, use cases include fixed backhaul between relay node and the core network. 5G QoS classes are adjusted, as well as new radio access types are defined. CT1 working group is responsible for defining protocols between UE and the core network, as well as UE's network selection. In addition to this, NAS protocol timers are studied, and the design changes are also impacting SMF, PCF, and CHF. New satellite access types are defined in terms of NR-NEO, NR-LEO, and NR-GEO. Finally, IoT NTN is the place where the LTM and NB-IoT are expanded to include the NTN work. This slide shows a nice tabular format of the 3GPP NTN work. Moving on. It is expected that the standardization would be completed possibly 2022. We'll see. Keep fingers crossed. Early prototypes are have been developed based on the collaboration between research institutes and European Space Agency. Some of these projects are mentioned here. Okay. A Quadriga radio channel model is has developed a simulation package that is available for public use and research use. The figure on the left shows a driving course of 800 meters on which the car is traveling through twists and turns and curves, is supported by an S-band satellite. The figure on the right shows the behavior of speed of the car versus simulation time of 100 seconds. You will notice the points where the speed is 0. That means the car is stopped at a traffic stop, or it is paused at a crossing. Further, the third result shows the beam footprint for the S-band satellite. S-band satellite is equipped with a parabolic antenna of 3 meters in diameter with a left-hand circular polarization. The terminal antenna is using a dual polarized antenna and is pointing towards the sky. So um, um, the corrected calculations can be verified using this beam footprint. Finally, the last diagram shows the behavior of RX power versus simulation time, and you will notice the trend is changing based on different events that occur during the simulation and different environment and channel conditions. Okay, have we answered the why? Why is NTN important? So based on the review, we have seen specific requirements and specific design consideration for those requirements along with challenges. And challenges are still being worked on, has been explored in standardization process, including the feeder link outage due to the atmospheric attenuation and some revenue shortages as well. In summary, NR is expected to play an important role um, in adapting to the NTN scenarios, and also to overcoming some of the limitations. The ultra lean design of NR has made it possible for it to be expanded to include NTN effectively. And finally, different application scenarios for unserved and underserved areas will benefit immensely due to the integration of terrestrial and non-terrestrial networks. Thank you for your attention. And with that, I hand it back to Ganesh.
Excellent presentation. Thank you, Uttara. Thank you so much. Now, moving on to the next speaker, let me introduce Anchal Sadana from New Delhi, India, to present on 5G changing NEP landscape.
Yeah, hi everyone. Can you see my screen?
Yes.
Yeah, hi. Hi, my name is Achal Sardana. I work with HCL Technologies and I am a 5G solution evangelist. And today I'm going to cover a topic how 5G is changing the landscape of NEPs. When I say NEPs, it is network equipment providers, or some call it as OEMs. Okay, so let us see how the 5G, what are the asks of 5G from these NEPs, how the landscapes are changing, and how the behavior of NEPs is impacting its customer. So let us start from what are the asks from NEPs. So if you see, 5G has incredibly changed the landscape of all its ecosystem players, not only NEPs, whether it is CSPs or it is silicon providers or even hyperscalers. Though if you see, hyperscalers are also the OEMs or the NEPs, and they need to categorize under that. But the way hyperscalers are transforming themselves, they play altogether a very different role in the ecosystem. And I have not covered them as part of NEPs. I would like to cover them sometimes separately. Okay. So now let us see what are the asks of 5G. So when I say 5G, 5G is basically pushing these OEMs or NEPs to build cloud native functions which are disaggregated. And when I say cloud native functions which are disaggregated, it means any type of hardware can work with any type of software and vice versa. So that is an immediate requirement of the 5G. The second one is 5G want to give room for innovation to most of these customers, right? Whether it is telcos or enterprises. So it wants that these NEPs, whoever is manufacturing the products, they need to have the open interface, right? Open APIs, so that when anytime there's this need for customization, these interfaces can be worked on and there's always a room for innovation. So that is the second ask. Okay. When I see the third thing, 5G also provides these these OEMs and NEPs to expand into various areas like private network. It's an technology in itself, right? There's a lot of work that needs to be done, open RAN, edge computing. So it is pushing these NEPs that you need to expand your footprints in all these newer areas which are coming with 5G. The fourth one, if I see the 5G for its MEC and private networks, it motivates NEPs to look beyond its traditional customer. So who are the traditional customers for these NEPs? The traditional customers are communication service providers. So it pushes them to look beyond CSPs and go to new enterprises to do collaboration and partnerships. And last but not the least, with IoT coming in, with 5G bringing millions and millions of devices connectivity, 5G is pushing these NEPs to make a lot of investment in the IoT side of the house, investing in the data center infrastructure, because everything will be cloud native. So a lot of investments need to be made by these NEPs. So these are some of the key asks that 5G has from the NEPs, right? Now let us see for these asks, what are the changes that these NEPs are making so that they fulfill the requirements of the 5G. So these are some of the trends that I have captured. So number one, Let's see the new player emergence. So if you see the traditional ecosystem, they've been dominated by key three players. One was Nokia, Ericsson, and Huawei. But with 5G, there are many new players which have come in the market. Like if you see Mavneet, okay, it is dominating the Open RAN market, parallel wireless, Open RAN market. Mavneer with its CUDU, Benetel, it is only focusing on the RU side of the house. Foxconn, again focusing on the RU side of the house. There's the Altio Star coming in, CASA coming in with focusing only on the core side of the house, 5G core, right? So one is 5G has opened doors for many new NEPs to emerge. That is the number one thing. Second thing is these NEPs, what they are doing is they are collaborating with hyperscalers because they understand cloud is a very, very important area. If you see last month, there are two recent announcements which two big players have made. One is Nokia. It is collaborated with all the three hyperscalers, right? Whether it is AWS or it is Google Anthos or it is Microsoft Azure. Recently, Ericsson has also announced a partnership with AWS on the edge side of the house. So they do understand that to capture the 5G market, it is very, very important to collaborate with, to partner with hyperscalers, because the cloud capabilities which these hyperscalers have, it is difficult to match the ground, right? The next thing is new enterprise customers, right? So it is, they are not only focusing on the telcos, but their focus has now shifted. Apart from telcos, they're focusing on expanding and working with new enterprise customer. Ericsson, it has worked with Airbus alone, okay, just with another system integrator, small company, to develop the private network for Airbus, right? So they are looking how they can collaborate with enterprise and not only focus on the operators or CSPs, but to move much ahead from the CSP focus and more focusing on the enterprise side of the house. Collaboration with silicon players. Now what they have done is, once they are basically collaborating with the silicon players. If you see Mavni, okay, it has collaborated with Qualcomm, which is one of the silicon players. Okay, another collaboration with silicon player is Ericsson. Okay, it is also collaborating with Qualcomm on the silicon side of the house. Okay, then what I've seen is that silicon players, they also want to emerge as NEPs, right? If you see Qualcomm, it is developing its own radio platform. Okay, if you see Xilinx, it was a simple silicon company, but now it has come up with router because they see that there's a lot of room to play in the NEP market. If you see Intel, it initially started with a silicon player developing chips, but now it is developing smart edge platforms, right, for the edge computing side of the house. So NEPs, the way NEPs landscapes are changing, the competition is increasing. Silicon players are becoming NEPs. Qualcomm has come up with its own radio platforms, right? The other one that I see is, one second. Yeah. Okay, so these are some of the trends that we see in the NEP market. Okay, and now let us see how these NEP trends are actually impacting their customers. Okay, so we have seen what are the asks for 5G from these NEPs, how NEPs have changed themselves. Now, let us see how this NEP landscape has impacted its customer. And when I say its customer doesn't restrict itself to telcos, but also move beyond telcos, which are enterprises. So first and foremost thing, it has made the network of the telcos very agile and flexible because it's a multi-vendor ecosystem now, which telcos have. Okay, they have multiple hardware vendors, they can have different software vendors. So it is very flexible. They can pick and choose. They're not dominated by those three traditional players, Nokia, Ericsson, and Huawei. Instead, they have a lot of room to play with the OEMs, right? They can pick and choose any OEM which they want to work. The second is they are redefining the way enterprise needs to work. Now enterprises are looking much beyond getting that normal cellular connectivity. They are looking how they can automate, how they can bring automation. There are various enterprises use cases which are being worked out, like inventory management, manufacturing insights, how do you get real-time insights. Okay, so it is actually changing the way these enterprises are working. It is 5G is redefining, especially with NEPs, the equipments that are coming in, it is redefining the way enterprises are working. And obviously, with all these changes, NEPs are providing a room for innovation in both telcos and the enterprise side of the house. When I say room for innovation, we have this open APIs, the open interfaces. They can do a lot of customization on the interfaces, and even they're going for developing their own customized solutions because the interfaces are not open. They can do any type of customization which they want. But when we see the pros, there's also one con which I see. And with so much of multi-vendor ecosystem that has come in the CSP's network, also in the enterprise network, it has actually made the network complex. Because now what has happened, there's no single neck to choke, right? For these CSPs and enterprises, they need to contact multiple NEPs. It is difficult for them to maintain multiple versions of hardwares and softwares, right? Because when you have to perform upgrade, you need to maintain. It is difficult to carry out the RCF because you have now multiple vendors in your ecosystem. So in a way, if you see with the way NEPs are transforming, right, though there's a lot of room for innovation which they have opened, they've made the networks agile, they've opened new room for innovation for the enterprises, they've redefined way of working, but at the same time, the networks are being more and more complex. So with this, I come to an end of the presentation. Thank you. Kanishwam, you are speaking on mute.
Thank you. That was a brilliant presentation. Thank you so much, Anshad. Let's move on to the next speaker. Let me introduce Yudi Rahadian from Düsseldorf, Germany, to present on the 5G Open RAN.
Hi, thank you, Kaneshwaran. Allow me to share, please. So first of all, thank you very much for inviting me. I'm very happy that I can participate in this event. And warm regards to the all speakers. Nice to know you all. My name is Yudi Rahadian. So currently I'm working in Germany, in Düsseldorf, exactly. So briefly about my career. So I'm starting as a rigger or field technician back in 2001 and 2005. So I'm very happy about that because that's how I started my career in telecom world. And between 2005 and 2012, I'm working about in 16 countries as a telecom consultant, mostly in core and RAN. So that time I was working mostly with the Ericsson vendors. And between 2013 and 2017, I started my career in Germany as a telecom consultant, as a freelance, working with mainly with the operators here for 4G and 5G technology. And starting 2017 until now, I try to expand my career to have a company here, consulting company called TechBros. So since then, we've been working closely with the Open RAN technology and also the 5G technology with non-standalone and standalone as well. So my main expertise is for the 4G, 5G multi-vendor experience, Open RAN solution integrator, business developer, AI product manager, agile coach practitioner, and I'm also the customer interface for telecom operators. Yeah. So I would like to talk about the Open RAN. So probably, as you know all, that the current technology called Open RAN is standardized by the ORAN Alliance. The benefit is that for the network, for the telecom operator, they can reduce the capex, the opex and capex, especially in the rollout, because they are just aggregate between the vendors. Let's say now we have the legacy vendors only using one black box, let's say, but the Open RAN they are using white box, which is can also disaggregate between the DU and the RU as well. And of course, the benefit of the Open RAN is that they're improving the network of efficiency and performance with the AI technology, with their technology so-called the RIC or Radio Intelligence Controller, which is divided to near RT and also non-real-time RIC. Yeah. And they are also capable of importing the new capability with a great agility using white box label hardware, meaning that they are using the merchant silicons They are not depending on any hardware, let's say. They are just using, you can develop them from the O&M hardware, like from Dell or from IBM and so on. And the Open RAN technology, they are also using the cloud native technology, which means that easy for scalability. So whenever you would like to upgrade your network or like to upgrade your capacity and software, there will be no necessary of downtime. So meaning that you can still use the current traffic in service, and as well, you can also improve based on the needs from the traffic from the network itself. Yeah. The last one is that Open RAN bring more new innovation and passion for wireless use case, because currently there is so many ongoing development and deployment as well using CI/CD in the RAN technology itself on the under the telecom infra project consortium. Therefore, we have opportunity for us as Open RAN solution integrator also, or Open RAN system developer, to contribute to develop more that the technology Open RAN can be more achievable. Yeah. And the next one is Open RAN as a service. So here Open RAN is adopted in the system using radio intelligent controller and traffic steering, as I mentioned earlier. So the radio intelligent controller means that the technology itself using machine learning and the AI, which they can study themselves, and then that also can predict what will be the failure happening in the system, and then they will fix it themselves. So this is called the radio intelligent controller. So that's not necessary for man-man interface to fix the problem and to try to find what is the root cause. So the machine itself will trying to solve the problem itself. And the second is traffic steering. Traffic steering means that we know that there is so many how to say use cases coming from the cell itself or from the UE itself. They can also understand the QoS flow, and also the radio priority and the parameter what need to be improved. So meaning that let's say that the network have a congested issue, then the technology Open RAN, they will understand it, and they will also try to improvise themselves the technology. Yeah. And the second one is Open RAN technology uses the UE-centric method, meaning that they are fit for the vertical use cases, which is currently intended for the 5G technology, I guess, because 5G technology mostly they are intended for the vertical use cases like smart manufacturing, smart factory, and so on, which later on can be also improved using the UE-centric. So the Open RAN technology will understand what is the need and what is use case currently used by the UE. So like what we understand now, the legacy RAN, they are mostly cell centric. So meaning that whenever you try to optimize one cells, then the affected will be all the UE under that cells. But in the Open RAN technology, they are more to QE centric. So you can specify which kind of QoS, which kind of parameter, which kind of traffic flow that you will need for the use case itself. Yeah. The next one is the Open RAN support the RANAS, or radio access network as a service, where applicable use case can be in the radio can be implemented. Let's say V2X, car to car, agriculture, healthcare, and manufacturing industries. Of course, each of these use cases have a different treatment or special treatment, which we cannot occupy with the current legacy network, because we have now currently the private network, but nevertheless, there are so many use cases with the different needs. So there is always need the customization, or also need some adoption in the radio network itself. Yeah. The next one is I would like to explain you briefly regarding the difference between legacy 5G and the 5G Open RAN proposal. The legacy 5G based on 3GPP, as we know that they are containing the CUCP and CUP, and the front haul itself, the interface between DU and CU, they call it F1C and F1U, which is divided because of distributed technology architecture, between the control plane and user plane. But for the Open RAN itself, they are optimized using the technology called near RTRIC, which means that the decision from the DU or from the RU can be also depend on the use cases that require based on the latency. Let's say now you need very low latency and you require some fast action from the core network or from the UPF, then the near RTRIC will directly take decision and send it through the interface called E2 and send it directly to the ODU what is required. So it will be like bypassing. Yeah. So this means that the technology for the so-called RIC or radio intelligent controller is very advanced than the current legacy 5G technology, which will later on also how to say combine between the CUCP and the CUUP as well. What is required as well. So it's also depend on the latency or the use case that they require in the field. So currently we are now involved very actively for opening the Open RAN ecosystem, especially in Indonesia, where the place I'm coming from. So we are collaborating with the university, Telkom University, and also Telkom Infra project. They opened the first Telkom Infra, Open RAN lab in the Telkom University. Is covering the Asia Pacific, so the first time that they opened there in Indonesia, and then later on they have also the agreement with the operators that because Indonesia is contained with many islands, 17,000 islands round about, and not all island can be covered by the technology, wireless technology as well. So therefore, the Open RAN is very fit and suitable for this kind of rural deployment. And also urban, of course, but mostly we are focusing on the rural area to cover. And the third one, we are currently trying to build some awareness about the Open RAN use cases, also about the impact technology can be caused by the Open RAN technology. So I think we already held fourth webinar. We invited some speakers as well. Probably if you're also willing to become our guest speaker in the next event, so we are most than welcome about this awareness, because currently there is a big needs there, especially now we know that everybody's working from home, but not all having an internet connection. So it's a mandatory for people now to have internet, but not so. But from the telecom operator itself, is a big challenge how to roll out in the whole countries. Yeah, using the without the Open RAN technology. And also we are planning to build the local skills and capacity in 4G and 5G white box hardware manufacturing, assembly, and system integration as well. So we are hoping that because Open RAN technology is really open source, using open source technology, we could also develop or trigger the local people to build up their own Open RAN technology. So therefore, this is very big chance for us to not only developing the technology itself, but also can be impacting in the local economy itself. Yeah. And the last one is, of course, we encourage not only from the pipeline itself, from the Open RAN 5G pipeline itself, but also from the use cases, the monetizing use cases. So they're going to be like ecosystem with the startup also, and also with some of small company, medium enterprises as well, to develop some use cases using Open RAN technology, and of course with the private network itself. Yeah. Yeah, I think that's all from my side, Kaneshwaran. Thank you very much, and I wish you all have a nice day. So I give you back the forum. Sorry, Kaneshwaran, you're still mute.
Thank you, Yudi.
Yeah,
That was
welcome.
thank you so much. Let's move on to the next speaker. I would like to Fahim Indra from Telkom
Yeah,
and on the 5G private network.
yeah. Thanks, Kaneshwaran. Can you make me the co-host because I'm not able to share my screen?
Done.
I hope you all can see my screen now.
Yes, perfect.
All right. So thank you, Ganesh, for the introduction, and thank you for this opportunity to present about 5G, and especially on the private 5G side. One of the things that we have been noticing in the recent times, and all the headlines that you see coming in from the technology side, especially on the connectivity, is around how 5G is going to change the world. And one of the things that has now become the focus of most of the telecom operators, as well as the connectivity providers like Nokia, Ericsson, and Huawei, is to target and explore the opportunity beyond the network providers and get into the enterprise space. And I think that is where the power of private 5G comes into picture. Uh, a small snippet of what 5G can bring to the table by 2025 is that it is estimated to connect around 35 billion devices by 2025. Uh, Obviously, this number looks huge on paper, but if you look at the number of devices that exist today, it is already reaching at around 10 to 15 odd billion of devices, taking into account every sensor, every device, every mobile that is getting connected to the network. And the impact of this is not just going to be in the developed economies, but it is also going to impact across the world, even in the third world economies, where the opportunities of connectivity is much higher. Especially if you take the example of India, you see that the number of mobile users is extremely high in India, and even the usage of data and mobile broadband is extremely high. So the impact of cellular is widespread, and it's a proven technology which can then be applied into the enterprise context. What I would like to show you is that how 5G is bringing unmatched latency gains in the industrial use cases. One of the challenges that is primarily being tackled in the industrial scenario is that how can you replace wired connectivity with wireless and maintain the same level of latency that you would require for the successful operation of the use case. If you move from the left side of the picture to the right side, you will see that the latency requirement increases significantly, starting from 100 milliseconds, which is required in most of the automation scenarios that exist today, like PLC automations or asset sensors like temperature and humidity sensors, which do not require the data to be transferred at a very high pace. But if you look towards use cases which involve AR, VR, push to talk, and continue to move towards the right, the amount of data that you need to transfer and the latency that you would require in order to transfer that data increases significantly. So the latency goes down, but the data volumes go high. And that is where the power of 5G comes into picture. And most of the industries have started to realize the value that 5G can bring to the table. Obviously, it does not come with all bells and whistles in terms of that it's not just advantages. It has its own drawbacks. For example, millimeter wave has its own interference issues when it comes to industrial automation. But if you look at most of the general scenarios where you utilize Wi-Fi based connectivity, they can easily be replaced with 5G connectivity, which is much more reliable, robust, and also is built upon the cellular infrastructure, which then provides or enables a much wider connectivity, especially at a global scale. Uh, what I would like to show is the technological superiority of cellular connectivity. Uh, the advantage that cellular brings to the table is that you could use multiple number of radio dots to create a cellular network, which then acts as a single network. And the large cell sizes avoids the dead spots in any type of connectivity. So especially if you look at use cases, say around AGVs or guided motion or even autonomous operations of robots, uh, the connectivity becomes very important, because you cannot lose even a moment of connectivity. In that case, there might be some loss of data, as well as there might be loss of control. When you compare that against what is currently available from technologies such as Wi-Fi, you see that there will always be handover issues, which may lead to dead spots, which may lead to a loss of control. And this is where cellular really shines, that it is able to build a seamless connectivity network, which can be leveraged across multiple industries. If you take, for example, industries such as oil and gas, where you can't leave a pipeline monitoring even for a millisecond, because a small leakage can also be disastrous to the operations of the factory, or even the gas pipelines that run across the land. Uh, so the advantages that the cellular brings to the table is quite high. It is highly reliable. It can support a much larger device density. It is built upon the proven security of the cellular technologies, which we have been using for quite many years now. The latency is predictable and consistent. And then you have much more control over the cost that you incur when you are establishing a network, especially when you want a seamless, strong network that is, avoiding any kind of dead spots, and also helping you build a resilient network. And it's obviously a proven technology. Billions of people are using mobile connectivity all over the world every day and every minute of the day. And just to give an example, this is not something that is a pipe dream. It has already begun. In fact, a couple of days back, Nokia announced that they are working with Equinor, which is an energy provider from Denmark. They are building a 5G ready private network for Equinor, especially for their offshore wind farm operations. Similarly, Ericsson actually has been leading the pack with their robust offerings around 5G, and they have been doing that with Deutsche Telekom for BMW. They recently did a setup for private networks for Airbus, and they are also the partners for the French airports, the Charles de Gaulle Airport in Paris. So this is something that is not going to stop. It is definitely picking up steam. Network providers as well as enterprises are realizing the importance of this, and they have already started to take steps towards the implementation of private networks. And this is just the beginning, and we hope to see more to come in the near future. So that's all from my side, brief on the private 5G and how it is going to shape up the enterprise side of things in the near future. Thank you, Ganesh.
Thank you, Fahim. Brilliant. I appreciate that. And let's move on to the next speaker. I would like to introduce Samuel Idiagu from Canterbury, England, UK, to present on the 5G Open Radio Access Networks.
Thank you, Kanish, and thank you for inviting me to this conference. Now, I'm going to give a different view from what the previous speaker, Yudi, spoke about in relation to open radio access networks. And I'm going to give an overview of the ecosystem and the most recent events happening in the ecosystem. So I'll give an overview, open RAN adoption, and also look at policy and regulation measures being taken around the world. Now, I'll give an overview of what the Open RAN groups are. There are three major groups which are in the ecosystem. The telecom infrastructure project started in 2016 by several operators and backed by Facebook, has a project group called Open RAN. If you notice, there's no space between the open and the RAN. So that's one thing one has to take note of. But they are focused on field trials and deployments of RAN solutions. The ORAN Alliance, where the O stands for open, is a group that focuses on technical specifications for open interfaces. And of course, between TIP and ORAN Alliance, they have collaborations. Now, the third group, which is the most recent one, is the Open RAN Policy Coalition. And they are more or less a lobby group, which tends to promote policies to advance Open RAN adoption around the world. Now, in relation to radio access networks, the shift has been happening from closed and proprietary systems to open and disaggregated. And if you look on the left here, you have what is a traditional RAN, where you have proprietary hardware and software, where you have a single vendor providing all of the components. And in the telecoms market right now, the three major vendors control about 80% of the market share. So this shift from closed and proprietary to open and disaggregated started with 5G, where the functions in the baseband unit have now been split into two new elements called the DU and the CU. And you have this open frontal interface, which allows you to mix and match components from different vendors, unlike, like I said, the present situation where you have three major vendors controlling 80% of the market. Now, I'm going to take a look at the ORAN Alliance architecture. Now, I'm not going to go into detail into what is happening here, but the key thing to take away is that new functions and new interfaces have been added in this architecture for Open RAN. And the major function that has been added is what is known as a RAN intelligent controller. And the RIC leverages AI and ML algorithms for automation and orchestration, because with 5G, there's going to be a lot of data being generated. And the introduction of the RIC will enable one to use all the data being generated from millions of devices connected to the network for automation and orchestration, and also the input of third-party software applications into the RAN. Now, I want to take a look at what are the Open RAN deployments taking place around the world. Now, the major deployments by operators, starting with Rakuten Mobile in Japan, who has launched a 4G LTE network based on Open RAN, and 5G also. Dish Networks in the US, which is building the first Open RAN based network. And most recently, the 5 major operators in Europe have signed a memorandum of understanding to deploy Open RAN networks from 2022. And yesterday, they released the technical requirements for what they need to make those deployments for people in the space to take a look at. Now, also the Indian operators in India are also looking at using Open RAN for 5G rollouts in the future. Now, governments around the world are looking into diversifying the telecom supply chain for 5G, and they are putting in place certain policies and regulations in order to achieve that. So I'll take a look at where I am in the UK and look at the various labs, test centers, test beds that have been announced in the most recently. And starting with NEC of Japan, they're opening an Open RAN Center of Excellence in London. And also they have a test bed coming up in North Wales, most likely next year. Vodafone of the UK also announced a new lab in Newbury. And the two of the, let's say, 4 major US-based Open RAN software vendors, Mavenir and S-Span, have also announced Open RAN centers or labs in the UK. And the last one is known as the Sonic Labs, which is a collaboration between the UK's innovation agency known as Digital Catapult and the UK's communications regulator, Ofcom. They are opening a lab, which is going to be launched in 2 weeks' time in London and Brighton, in collaboration with 9 vendors in the Open RAN space. So like I mentioned earlier, the diversification of the supply chain for Open RAN and 5G is important for governments around the world. and they have put in place certain policies, or they're putting in place certain policies and regulatory measures. And I'm going to look at two major countries, the US and the UK, and see what kind of policies they are putting in place. Now, in the United States, last year, the US House of Representatives authorized a bill or an act where they are promoting Open RAN over 10 years with the total amount of $750 million. And most recently, in April, the US communications regulator, the FCC, put out a notice of inquiry to receive comments on how to accelerate the deployment and development of Open RAN in the ecosystem in the US. In the UK, the similar thing has also been happening since last year. The government published a report known as the diversification strategy, where they are planning to commit £250 million, equivalent of about $350 million, to implement 5G Open RAN in the UK. Based on that report, they set up a task force, and the task force recommended the following: that the UK mobile operators, there are 4 of them in number, they propose that they use Open RAN across 25% of their networks by the mid-2020s, and also that the UK government provide investments to support Open RAN deployments by 2022. And of course, in the House of Commons, there's also been major discussions around the market diversification of 5G, and they also have came up with a report which the government has responded to. Now, in all that, in summary, I would say that the key thing to take away for Open RAN is that there's a new element known as the RAN Intelligent Controller, the RIC, and with that, it brings AI and ML into the RAN, and diversification of the supply chain is driving Open RAN adoption. Also, governments are supporting the Open RAN initiative in as much as the operators are doing the same thing. And lastly, the UK is becoming a global hub for Open RAN research and development. Thank you for your attention.
Awesome insights. Thank you, Samuel. Appreciate that. Now, moving on to the next speaker, I would like to introduce Akel Sharaf from Brittany, France, to present on 5G and beyond.
Thank you. I cannot yet share my screen. Can you please enable me?
I've already given a co-host to you. Are you able to share?
Yes, now it's okay. Okay, so thank you for inviting me for this conference, interesting topics. So my name is Akel Sharaf. I'm R&D consultant working also on standardization in 3GPP RAN4. So I will be a little bit more microscopic about this 5G questions, and try to give a mix between some market insights and technology insights. And then I will move to some feedback from Industry 4.0 and its impact by the COVID-19 pandemic. Then the evolution of 5G and interaction with artificial intelligence and the way forward for beyond 5G and 6G. So as you know, IMT 2020 was designed to fulfill 3 main categories of applications: enhanced mobile broadband, ultra reliable low latency communications, and massive MTC. And it seems that 5G has succeeded to fulfill all of these requirements. Today, the deployment worldwide is ongoing. We have 162 commercial networks launched already, 435 operators investing in 5G, including 162 already launched services compliant with GPP specifications. And we have also 703 devices announced, 5G devices, including 50% of these devices are mobile phones. So this means that the left 50% of 5G devices actually corresponds to IoT and massive MTC and ultra reliable low latency communication devices, which means that 5G actually is really relying too much on this part, the industrial part and the IoT part, as previous speakers mentioned also in their presentations. So some feedback from the COVID-19 pandemic surveys. So the digital transformation has been impacted by this pandemic, mainly on all levels, and especially Industry 4.0. But it seems that the main lessons, the role of the networks, high capacity and resilient networks, is becoming more and more important. It's becoming a cornerstone in our societies for e-learning applications, for e-health, remote work at least. But still the other part, which is the industrial part. That's why we think that reliable networks and resilient networks, as the ones offered by 5G and its evolution, will be necessary really for a post-pandemic recovery. So to consolidate these findings, I will just share with you this slide, a little bit complicated to read, but this is a feedback from a survey done by McKinsey. So actually, they divided the Industry 4.0 components into 3 categories. And they noticed the adoption between no adoption at all and rapid acceleration in adoption. And also, they considered the existing technology infrastructure for Industry 4.0 as a parameter. So the left column here will give the findings based on companies without important investment in technology, and the right one for companies having already invested a lot in Industry 4.0. So as you can see, for everything related to digital work, so all components related to software improvement and enhancement, we have seen a very accelerated adoption, even for companies having no existing infrastructure. If we go for a little bit heavier components like advanced analytics, like digital twin simulation, like robotic process automation, so we can see that we have also some slowdown, but we can see that the companies having already something existing, advanced technology infrastructure, have adopted more quickly than others, Industry 4.0. Now, when we go to the third category, which is the heavy industry, dealing, for example, with nanotechnology, with 3D printing. So here we can see that the Industry 4.0 adoption has been really slowed down. And there's no difference between companies having already invested or not. So this means that the heavy transformation in Industry 4.0 didn't yet happen. And we believe that 5G ultra reliable low latency communication, so 5G private networks and IIoT, are really the key enabler for this transformation. So the best is to come for 5G. Now let's talk a little bit about the evolution of 5G. So as all of us know, first release of 5G has been released in December 2017. Basically, sorry, I will just on this. So the strength of 5G and the enablers of its current evolution rely on the native flexibility in 5G design and its forward compatibility philosophy from day one. So the air interface of 5G is really flexible enough to support all these use cases we mentioned, from enhanced mobile broadband to industrial IoT to ultra reliable communications. So all these are taking place on the same physical interface. This is the flexibility 5G offered, plus the other features on higher levels like network slicing and like network function virtualizations. And plus the wide spectrum coverage by 5G. So as you know, 5G covers a spectrum between 600 megahertz up to 100 gigahertz. So this is really a very wide spectrum with different characteristics, and the 5G is today able to deal with almost this all of this spectrum chunks. By the end of this year, release 17 will be finished and release 18 will be started. By the end of this month, we will know a little bit more about what will come in release 18 on all levels. So for example, around one group, we may expect enhancement for mobile broadband supporting cross-reality applications. In other groups, like for example, around 4, we are seeing extension of NR technology to fulfill higher frequencies, such as the 71 gigahertz band, further enhancement of massive MIMO and positioning, the high-speed train for millimeter wave, the satellite applications, and of course, continuous enhancement of side link applications. So as you know, side link means the PC5 interface basically done to support V2X applications, but now it's taking a wider set of applications. So this will continue. So one point is also to notice that 3GPP SA1 already defined requirements to support federated learnings. So for example, federated learning applications require an uplink up to 1 gigabit per second throughput and tens of milliseconds of latency, which is not easy to fulfill. So today, 3GPP SA1 defined these requirements, which will come later to run groups. Other possible evolution we may see actually in release 18 introduction of artificial intelligence and machine learning in some blocks of the physical layer chain. Actually, today we may use already machine learning and physical layer in a transparent way, without any specification impact. For example, for domains like channel estimation, decoding, power control, resource allocation, beam management. Thanks to edge computing, we may today integrate artificial intelligence already within existing 5G networks. And there is no need to add specific specifications. So this is something that started, I believe, in some of the commercial solutions and will continue, as well as in QoS management, for example, for core network. I believe that artificial intelligence and machine learning are already applied, but this can be seen today as a complementary features and components for 5G evolution. One interesting point to mention is that 3GPP RAN 3 is already working on a study on the RAN intelligence, mobile data analytics, and TR coming from SA1 28.A09. So this is not intending to define the machine learning algorithm, it's defining the framework for operators to be able to integrate machine learning with the existing specifications. One of the examples is the self-organizing networks, for example, which with artificial intelligence may move from a reactive philosophy to a proactive philosophy. So now let's go a little bit further about 5G evolution. So as all of us know, artificial intelligence has known a very big progress in the recent years, thanks to evolution in the hardware technologies. So now time has come for artificial intelligence to give back to semiconductor industry, which enabled artificial intelligence emergence. We expect actually that artificial intelligence combined with industry 4.0 processes and programs may introduce a new era in manufacturing for semiconductors and of course for all the stakeholders in this industry. One of the things we can expect, for example, by implementing machine learning in the manufacturing processes in this heavy industry, we can achieve gains in quality and performance of the chips or the components. We can save some manufacturing costs and time to market. And this will, of course, impact all of the 5G I would say ecosystem. So the change in device manufacturing price, the performance may introduce significant changes in the ecosystem. I would say, for example, the impact on standardization is to be considered. For example, if in 5 years we will see a new generation of chips built based on machine learning and artificial intelligence technology, so we may actually expect that these chips and these components are well mastered, which means that the standardization should take into account these points. So if you are familiar with some of the details of standardization, for example, in RAN 1 and RAN 4 groups, when we define some protocols and some algorithms for the physical layer, we need to take into account the power amplifier models, the phase noise models. In RF requirements, for example, we need to take into account the blocking, the interference from other technologies, the coexistence. So all of these domains will be impacted by the introduction of artificial intelligence, and the way we think to requirements and specification may change because of that. So with that, I will come to one last point about this. So one of the things very time consuming and very expensive in today mobile ecosystem is the testing and certification. So test setups and test procedures are very, very heavy, very expensive, and very time consuming. The introduction of artificial intelligence may dramatically change the way we test and the way we define testing procedures. So I would expect this domain will be very impacted by artificial intelligence introduction. So all of these changes may not require a 6G. Actually, it will be in the middle between the 5G evolution and 6G. And so I'm not intending to be exhaustive in this evolution of 5G, but just a few examples. One of the promising technologies today and under exploration, extensive exploration and research, the reconfigurable intelligent surfaces. So
Excuse
this
me,
technology,
you have 1 minute to wrap up, please.
yes, okay. So this technology actually will enable us to take control of the radio channel. So I will move to this next slide. So the reconfigurable intelligent surfaces combined with artificial intelligence may completely change the philosophy we design transmitters and receivers, because today we deal with the channel impairments, with the mitigation, with the physical layer design, and with the link adaptation. So we may expect that the combination of intelligent surfaces and artificial intelligence will give us a better control of the radio channel and will simplify the design of the transmitter and the receiver. So yes, we can, for example, just a quick use case in a factory where we need the very low latency, very reliable network, implementing intelligent surfaces in this case may transform the wireless channel into a very stable channel close to a wired channel with a very stable performance, very stable reliability. So that's all I wanted to say for today. Thank you.
Awesome, Abdul Sharaf. Thank you so much. Appreciate that. Now, moving on to the next speaker, I'd like to introduce Abdul Rahman Sattar from Toronto, Canada, to present on the artificial intelligence, machine learning use cases in the 5G age and cloud. Abdul Rahman, can you unmute, please? We can't hear you. Would you mind to unmute yourself? Yeah, now.
Yeah, can you hear me?
Yes.
Yeah, sorry, I think I was speaking on mute. Okay, yeah. So thanks, Kanish. So hi everyone, I am Abdul Rahman Sattar. I'm the lead architect of cybersecurity analytics at TELUS. And at TELUS, my team is focused on building intrusion and threat detection systems for enterprise security. And we are also looking into IoT use cases such as smart city platforms and also connected and autonomous vehicle security. So today I'd be talking about AI on the edge. So using edge analytics, using edge for AI use cases. So I'll be focusing on the infrastructure part of things and also talking about the use cases. So when you look at the classic AI and machine learning architecture, I mean, this slide basically shows like a very simplified architecture at a very high level. So essentially, on the left, we have the device layer, which can consist of smart homes, smart cars, smart buildings, user equipments like mobile cell phones that would be sending data to the cloud, where on the cloud we'd be training AI and machine learning models, and then during the inference stage, these devices would essentially be sending data to data points to the cloud, where the machine learning models are applied to those data points, and the results are returned back to these devices. In some cases, the AI and machine learning models can also reside on the devices themselves, so that during the inference stage, that round trip time can be avoided. Also, in this case, from a telco perspective, the telcos are just passive pipes where they are just basically transporting the data back and forth without really doing any of the smarts within their networks. So this slide basically shows the GCP IoT architecture. So I've removed the telcos in this diagram. So essentially, what you see over here is that the Android IoT is registering with the GCP platform through the cloud IoT core, and the device would then, once it's registered, it would be sending data to the cloud through MQTT or through other protocols where there's the various services within the cloud stack that can process the data. So there's data flow and BigQuery that can do stream processing and batch processing and AI and machine learning on those data points coming in, and the results basically could be stored in Bigtable. So it's a serverless architecture, and then the cloud functions basically can sort of retrieve those results, can analyze those results, and can accordingly send action items back to the action items and commands back to the IoT device. So that's the actuator part of it. So the problem with this centralized cloud architecture, where the applications are making API calls or sending data points to some service in the cloud, and then the business logic depends on that whole backend service is twofolds. Like one is that there's latency issues with it. So essentially, there's this whole round trip time that has that basically happens because data has to go to the cloud. Some application has to service those data points, and then the results are returned back. And these latency can be significant for mission critical applications which require faster response times. The other problem with this whole approach is also data volume. So when we are looking at IoT devices, according to various surveys, by 2025, IoT devices would have generated around zettabytes of data. So it wouldn't be possible to upload all of this data to the cloud and process it over there and then send the results back, because that's just a lot of data. So that's where the edge computing and multi-access edge computing within 5G would essentially come in. So this visual basically shows how multi-access edge computing could be used for bringing the compute and storage closer to the user. So this is again a very high-level simplified diagram where the devices would now be sending data points, and these data points could be serviced closer to these devices. So essentially, the edge computing facility could be co-located with your base stations, or they could be co-located in the central office within the mobile network operator, or it could be co-located within the core. So it could be set up in various different ways. But the crux of this whole thing is that the telcos wouldn't be passive players in this ecosystem anymore. There would be more active players where the network infrastructure would be smarter through network softwareization technologies such as software-defined networking and network function virtualization. So the storage and the compute would essentially be closer to the user. And this would essentially avoid some of the pain points that I mentioned earlier in terms of latency and data volume. So over here on the edge, like you can have like AI and machine learning applications. You can also have like various like services serving API calls for these applications. So the network, like the crux of this whole thing is that the network the network infrastructure would essentially be smarter, and telcos wouldn't be passive communication pipes. So in terms of use cases, the various AI and machine learning use cases that we can have on the edge. I mean, I just want to talk about a few of them given the time constraints. So I'll give a high-level overview of how smart gateways can be used for pre-processing the data before it's sent to the cloud. Also, how edge computing could be used for intrusion detection using federated learning through the mobile edge computing nodes, and then also the Vision Zero project, which was started in Sweden for preventing road fatalities, and how edge computing can be used for taking proactive measures for preventing, for doing analytics and preventing road fatalities and coming up with recommendations. So this is for smart gateway. Smart gateways can be used for data trimming and pre-processing of the data before the data is sent to the cloud. So essentially, as I mentioned previously, IoT devices can be generating a lot of data, and it's not wise to basically just upload all of that that huge volume of data to the cloud. So it would be better to pre-process the data and aggregate the data on the edge before it could be sent to the cloud. So as this visual shows, these IoT devices would be sending the data to the smart gateway, which is on the edge, and the smart gateway can have some sort of pre-processing logic and aggregation logic, and it can also send data to the closest edge node or fog node, where further aggregation could be done. So this fog node would have like more compute and storage resources than the gateway itself. So more aggregation could be done on the edge or fog node. Also, you can train simple AI and machine learning models on the edge, and so the data could be aggregated both on the smart gateways and on the fog and edge node before it can be essentially sent to the cloud. Also, you can do privacy checks and de-identification of the data before you upload it to a public cloud. The other use case that I want to talk about is federated learning for intrusion detection using the edge. So over here, multiple IoT devices are sending data to their closest MEC nodes, and what we want to have over here is our models for doing for detecting intrusions and anomalies in network behavior. So one way to go about it, like in the centralized architecture, is that you send everything to the cloud, and everything is like those models are trained in the cloud, and you do intrusion detection that way, but that's not the most optimal way of doing it. So essentially, with this whole edge computing, we can take the federated learning approach, where once the MEC nodes get these data points, they can essentially, through a centralized cloud orchestrator, carry out a federated learning process where they would be learning models for intrusion detection. So essentially, you can learn, let's say, like deep auto encoders for intrusion detection using federated learning. So in this case, one thing with federated learning is that it's optimal in a way because data you don't have to exchange data points to learn those models. Like machine learning can happen collaboratively just by exchanging the model parameters. So in this scenario, each of the edge nodes would essentially get involved in this federated learning process. They would be exchanging parameters with the help of a centralized cloud orchestrator, and at the end of this whole learning process, each of these MEC nodes would have intrusion detection models that they can then use for detecting network anomalies and network intrusions. So the last use case that I want to talk about is the Vision Zero project, which basically started in Sweden, and now it's an international movement. And the whole idea of Vision Zero is to reduce road fatalities and road accidents. And over here, technology can play a big part by being more proactive about detecting the near collision incidents and undocumented, which would go undocumented otherwise. So the traditional approach would be that this data is basically looked at after an accident happens, but with technology and all the AI and machine learning infra that we have in place, one can be more proactive about it and can analyze data on an ongoing basis. And the visual basically shows a very simple pipeline where we can have smart intersections and smart cameras that would be collecting data on various intersections, and this data essentially could be analyzed using AI and machine learning approaches, and this is where edge computing can basically play a big part, because these data frames essentially from these cameras is a lot of data, so it's not feasible to send all of this data to the cloud. So one can have compute some AI and machine learning capabilities on the edge itself, where on the edge we can one can do vision, computer vision and object detection capabilities, and those those applications on the edge can extract the context, and that context can then be sent to the cloud, where the cloud can essentially then do like more historical analysis and correlate data from multiple mediums, and then send the results back for the analytics. So the edge can be used for setting for doing the more heavyweight work, so that we don't have to upload all of this image data to the cloud. Also, depending on the context, like let's say that if you want to do a safety use cases for pedestrians, then edge would have to play a big role, because you need sub-second responses over there. So the notification to the passenger that the vehicle is approaching, or vice versa, where you want to notify the vehicle that, okay, like there's a passenger on the road, has to be pretty fast, like needs pretty fast response times, and you can't afford to send this data to the cloud. Analysis would have to be done on the edge. So with that, I thank you all for your attention, and I pass the control back to Kanish.
Awesome, Abdul Rahman Sattar. Thank you. I appreciate that. Moving on to the next speaker, let me introduce Mikhail Zampak from Prague, Czech Republic, to present on the future enterprise infrastructure, cloud and 5G campus networks. Would you mind to unmute?
Sure. Sorry, I put myself on mute to not to disturb everyone. So good morning and also good afternoon to everyone, because we are at different time zones currently. So I would give you a short presentation on the, let's say, cloud infrastructure. So let me share the slides now. Going to full screen. It goes to full screen now. Good. So I hope you can see my screen now. Let me introduce firstly shortly. So I do work for Deutsche Telekom. Actually, I'm part of the, let's say, cloud subsidiary. So we are building internal clouds for Deutsche Telekom, and even it's a CSP. So we are really taking care of this seriously. And as I'm currently working as a business excellence manager, so we are looking to the practical implementation, and what does it mean for, and what 5G means and cloud means for the enterprises. Actually, a few speakers before me already mentioned that. So 5G will have a strong impact to the enterprise market, B2B mainly, because if it comes to speed, so for customers and B2C market, it will not be so serious change. But 5G is an ecosystem enabler, so you can, and we can gain by lots of things on that, and especially enterprises. And I will talk about the, let's say, combination of 5G and clouds, and how the infrastructure of typical enterprise might evolve in the future. And this will all depends on their, let's say, life cycle and renewal of the infrastructure itself. So starting simple, and actually I will not be about the theory, rather about the what is the real life. So here you can see something like typical enterprise these days. So you see there are some on-prem computers, there are wireless network inside, and there is a public network outside. And you see the whole enterprise campus, typically more buildings, some open space, and simply this is the way how typically, at least in Europe, the enterprise infrastructure looks like these days. slowly, sorry, you can see that it continues. So now everyone speak about the cloud, and everyone has something in the public cloud. So they are using some applications from Amazon, from Azure. So typically O365 is the typical public cloud application which everyone is using. But actually, it's suddenly they will find limitations on this, and at the same time, they will start to think about what to do with the on-prem. So they decided to change the on-prem servers, but if you see, they would go to cloud internally. Why? Because actually some data are private, so they should not be shared with the public cloud. At least in Europe, there are regulations, and companies are quite sensitive to that, to share something outside and let's say expose private data to, let's say, outside Europe. Same time, it was also mentioned a few times here, it's why the private cloud is here in the company because of the computing edge. So from that perspective, lots of applications in the enterprise will need a low latency. So there's no time to really send the data to the public cloud and back. Therefore, the advanced enterprises will really use private cloud and let's say edge cloud to really process the data and send only the relevant ones to the public cloud or some central store. So this is about how the infrastructure is really evolving, but what will happen with the wireless? Because actually also some of you has mentioned that one of the challenges is to get from wireline IoTs and wireline Industry 4.0 to wireless one. So currently, most of them are using kind of Wi-Fi, which works very nice in one of the, let's say, room or building, but still there are lots of limitations. If you look to wireless networks, so public one will go to LTE and 5G, while the private one can go two different ways. So the Wi-Fi 6, which is currently like next generation of Wi-Fi competing with 5G, has removed lots of things and is currently allowing most of the enterprises to do a lot of use cases, and it's quite cheap. While there is a private 5G for the enterprise, and one of the things we discussed is about why enterprises should go for 5G instead of and favorite instead of Wi-Fi 6. So actually, it's about the use cases. So actually, similar graph about let's say use cases was also displayed in one of my speakers before, and this shows the requirements per use case. And you see there are different quality requirements about the bandwidth, about the latency, and about the let's say amount of devices connected. And those use cases can be fulfilled by 5G ecosystem, while Wi-Fi 6 is somehow providing everyone the same. So from that perspective, you see Wi-Fi 6 can provide very good coverage. However, it's still on the public public spectrum, which might have some drawbacks, but actually cannot cope with the specific, let's say, use cases which are relevant, for example, for Industry 5.0. So some IoTs needs really very low latency. Some of them just need high, let's say, bandwidth. And Wi-Fi cannot cope so much with the quality of service, while 5G is, let's say, designed for that. So two things why. Frequency spectrum, Wi-Fi is using the public one. 5G has a dedicated, typically for the industrial applications, you would see usage of spectrum between 3 and 4 gigahertz, typically 3.4 to 3.8 gigahertz of spectrum, which is typically dedicated, at least in Europe, dedicated for, let's say, industrial applications, and can provide sufficient bandwidth. And actually, it's not interferent because it's dedicated for that. And as I mentioned, 5G compared to Wi-Fi 6 can provide you with the service quality, and it can be done through the slicing technique, which provides you a dedicated slice with your quality requirements. So this is very important for enterprises to understand what is the benefit for them on the campus networks. So if it comes to campus networks, so as I mentioned, so it's the private network which is used by the enterprise, and they can deploy it. What is also important, and was said also before today, I heard that, and actually I remembered, oh, this is something I also am going to present. So actually it's not CSP who is deploying 5G campus networks. Typically, all the manufacturers of these technologies can directly work with the enterprises. And it will become quite important and interesting market, because if you want to implement 5G campus network or the private network, you don't need a CSP. You don't need a public provider for that. You just need to have a frequency which you can get allocated based on local regulation, and you don't need a vendor. And sure, you need to have a scales to operate that. This is a different story, and I will not touch it today, but Alpha will come to the game. So actually, private campus networks from that perspective is something which the enterprises will use more and more, because Wi-Fi can work in small area, but the campus network and 5G can already cover heterogeneous spaces, also the outside one. So one of the learnings is currently that if you look to 5G campus network, it also works in the larger areas and can cover, for example, complete industrial complex quite easily and with good quality. And actually, currently, if you look to current deployments, because it has started, and for example, in Czech Republic, we are now deploying it for universities to create their use cases and in research on that. So it will start like a dedicated standalone 5G without public network integration, because the public 5G is not yet here, and the use cases would be more complex and complicated for the deployment. So currently you can see it's being like 5G standalone deployed and operated directly by the enterprise. Surely in the future, what will happen is that the 5G provider, the CSP, will be able to do a slice out of the, let's say, public network with the quality which is requested by the enterprise. But so far, it's not yet there. It will come in future releases also. And as soon as it is there, it can create also interesting combination of the internal network, which is used by the enterprise, and the umbrella network coming from the public stuff. So coming to the early deployment, and this is from the, let's say, 5G GSMA implementation white paper. And you see at the beginning, it will be really like campus networks being plugged in into the public network and being standalone, because currently the public network, at least in Czech and in Europe, is a little bit behind, and the collaboration or coordination of the networks will not be there. So currently you see like islands of the industrial networks coming to be deployed soon, this year and next year. And later on, also the, let's say, combination from public network slicing will come to the game. So to conclude, be very quick on that. So I think that 5G can provide a dedicated network quality layer compared to Wi-Fi standards, which will make an advantage for all companies who are really interested in Industry 4.0 and to be able to rely on the network. So for the industrial applications and for Industry 4.0, so 5G campus networks are quite crucial, because they can guarantee the quality through the, let's say, slicing of the quality layers. So it will start with the standalone 5G networks because it's easier to deploy, and there will be faster ramp up on that. And in the future, what I see, so the network slicing approach will allow companies to get flexible and maybe also easier, let's say, their quality of service for what they need. So this will come as with the new releases. So, and actually it's all from my side for today. I wanted to focus only on that, let's say, practical implementation, because very often we are questioned as a carrier from B2B segment. So why we should go to 5G when we have our Wi-Fi and currently works nice? So simply said, 5G has more, let's say, impact to industrial for the future. Thank you.
Thank you, Mikhail. Appreciate that. That was awesome. And moving on to the our last speaker, I would like to introduce Professor Dr. David Soldani from Sydney, Australia. to present on the 5G evolution, security controls, and assurance.
Hi, thank you for having me today. I think we have pretty much covered all topics. So what I would like to do now is just share with you a few slides, which I think I will attempt to depict all what has been presented earlier. And then maybe we have still 5 to 10 minutes to have some discussions, because one of the topics I'd be interested in to know more from all other speakers, it is about how could we achieve connectivity with decent services, say, in rural areas. So that's a topic here extremely hot in Australia, and many players are now discussing how to achieve this goal, and the government is preparing for massive investment. So let's go through kind of a few slides. If you allow me to share the screen now, let's see whether it works.
I did give you a co-host.
Yeah, just a second. I tried to find the button. Yes, I think that's is so while speaking, I've just added one more slide, hopefully fits into the picture. So I'm sharing the screen. Okay, so my talk is how can we achieve the ubiquitous connectivity? So we have been discussing this, I think, for maybe 30 years, and we are not still there. So now, okay, I think we all know about me. So I skipped this slide, and I want to show you where we are with 5G today and what we target by 2025 to in terms of connectivity, connected devices. That has been extracted from two important contributions. One is from the GSMA, the other one from GSA, that the organizations of the carriers and the vendors. And what do they say? So look at the prediction in terms of connections. Today, 5G is definitely on. So we have more than 230 million people already enjoying those services, and 86% of this population resides in China. China will continue to be the largest market by 2025, where we're expecting to have about 20% of the world population connected using 5G, and China still will be the one providing most of the services in terms of connected individual, which is expected to be 45% of the entire connected individuals. It's of course intended that it's not just about China. Actually, if you look at the percentage of the penetration globally, we have that the North America, together with the Europe and Asia Pacific region, will account for 90% of the 5G mobile connection forecast by 2025. And North America will basically be the one mostly penetrated, connected 220 million people, which is around 50% of the reachable population. Now, in terms of devices, their study report is of last month, so from May. It is constantly updated, but gives you an overview of the available devices. So commercially, you find already more than 430 devices, and here on the pie chart you have the distribution proportion of the different form factors. You see still 50% on smartphones, but we have a variety of CPEs for fixed wireless access and a number of other type of form factors. And here I'm thinking of any kind of modules, onboard units, and for having the possibility of connecting any kind of device, not just smartphones, but robotic platforms, unmanned area systems, and so forth. Here you have the support frequencies we should pay attention to, because the frequency relates to the capability we are having to widely spread, so achieve an economy of scale, those services. Of course, if you radiate like in Japan, US, at a very high frequency now coming, by the way, in Australia and Europe, I mean, the coverage is very restricted. So you have many complaints that they say, okay, look, I'm enjoying here outside my premises, outside this shopping center, 1 gigabit per second. As I am penetrating, I have an inter-system handover, or say a fallback to a service which really make impossible even to have a video call. So therefore, the majority of the deployments today are in the C-band, so we are around 3.5 gigahertz. And those are basically the spectrum largely supported by the different devices and the form factors. 3.5 gigahertz, 3.6 gigahertz, anyway, the C-band allow us to achieve the same type of coverage as the LTE at 1800. That is due to two simple features that the 5G supports, or the new radio supports from day one. In the downlink, we have I skip the roadmap since we don't have time. And the earlier speaker that I covered already, just to spend maybe a few comments on this. Radiating the C-band at that particular frequency, what we have here is the system on a new radio optionally support those, but the 4G radiates using beamforming and and also MIMO on top. So the beamforming, the downlink, allow us to say achieve better coverage and have the same coverage as I said at the 1800, so we can reduce the sites. In the uplink, which is in the reverse directions, we have many challenges because the mobile transmitted this frequency cannot have the same coverage as a terminal operating at the 1800 in FDD. And therefore, what we do here is to have the coupling approach where the dual radio can also support the same frequencies as the 4G system, by either sharing them in a time-wise or simply scheduling properly the signal so we can achieve the same coverage. Right, so if you look at the system, how that evolves, I think the earlier speaker that have covered well all pretty much all topics. And maybe allow me to say something more about the announcements now coming with release 16 and 17, and potentially also 18 and later releases. By the way, the narrowband IoT and DLT MTC, so larger band, continues in parallel. So all this massive IoT type of traffic that comes along with a 4G architecture will continue. It's not affected by the new radio. That technology will be there and it's gonna be enhanced for a very, very long time, as we don't have a clear solution coming from and with the new radio, as we are thinking of different type of use cases and pushing this technology more towards non-terrestrial networks. NTN, that as earlier mentioned, but allow me to stress here, because of the non-terrestrial type of networks, we have been using them as a backhauling technology, is still there. We want to have as an access technique. So that means me with my phone, maybe not this kind of phone, something similar, or it can be a stationary station. I need to have access to the services where I find myself. Here in Australia, if I drive from Sydney to Darwin, I should have that particular connectivity, and that connectivity can be achieved through satellite system. They are coming along now in various configurations, and we talk about geostationary, yes, but they are not so interesting because of the latency and other challenges we're having in place. What's coming out very hot are the very low Earth orbiting satellites, because they allow us to reduce latency. And when you look at the latency through the orthodromic distance, which is larger than the link you may connect via satellite, I think we can stay well below 5 milliseconds. And that's not just about accessing the services, but will also allow us to have very, very, very low latency and support other type of devices. The coverage is beautiful because the footprint of a LEO is expected to achieve, I mean, those guys, they are running from 300 to 1500 kilometers altitude, and they are rotating in about more than an hour across the whole planet. They have a footprint now from 100 to 1,000 kilometers, which is exactly what we will need, for example, here in Australia. Along with that, yeah, they have mentioned network slicing, virtualization, cameos on the RAN. The MBMS also will be supported, and that is important for verticals as well, because the broadcasters are now struggling, like in some places, to deliver a very high quality resolution multicast or broadcast system signal, and that could also come through the new radio. And then, of course, the security, which has been announced with respect to the 4G, will be further improved in terms of both security controls and assurance. The positioning, thanks to the trilateral way of mixing and matching the signal, we go down to 3 meters and 30 centimeters, which is extremely important, because if you think of connecting big objects, robotic platform, and maneuver them, or anyway have a remote control on them, you cannot do that only through using a GPS system, because it's completely unreliable, and say the way the resolution and the accuracy into move those objects is absolutely infeasible and impossible to do. They have presented well already the operands, so the way we want to disaggregate the system, and the 3GPP has already completely specified that, and then O-RAN Alliance comes along with other interfaces. But as you heard from the earlier speaker, also the analytic platform, so the platform for AI applications, completely specified for the core network services, those coming from the RAM. So we are pretty much there, and I do see plenty of benefits. So if you do some dimensioning, for example, by deploying a disaggregated system, you may see that the advantage, especially you will have, are to achieve large coverage areas at lower cost and large utilization of the resources. On the other hand, if you are diluting the system, you cannot have then higher performance in terms of latency, as well as in terms of capacity and speed. That's practically impossible. But as we speak, looking at the possibility of having large coverage, I think that by disaggregating the system, there will be advantages. And you may see here that in terms of connected radiating sites, we may shift from 10, where you are basically localizing the deployment, to a regional deployment of the central unit. We can have up to 100 sites, which may make the business case possible with a massive deployment of this disaggregated system in the rural areas, which is further facilitated by the introduction, which was not mentioned earlier, I think it's worth mentioning, by the integrated access and backhaul, because the spectrum is definitely a precious resource and not really available everywhere. So which means that if I am able to get my spectrum and I can use it for access, the same spectrum I can then use for access and backhauling using this feature completely standardized already in release 16. Then you will have also an evolution of the device-to-device communication, which starts completely supported, beautifully supported by the LTE, further enhanced with the introduction of new radio. And then, of course, as the new radio enhances its capability and features, we have also, I think, by 2030, the possibility of discussing and enjoying advanced and full automation while driving or while, say, moving a different type of object and machine, also facilitated by the fact that there will be plenty on board radio units that will facilitate this communication. Now, I have just a couple of slides to summarize what I have presented, but also what I think the earlier speaker disclosed extremely well, is what I am expecting by 2030 is this type of reference architecture, which would allow us to achieve a ubiquitous connectivity. So without entering into the details, we will have the possibility of enhancing our new radio. I'm thinking of release 17, hopefully supporting the unmanned area vehicles or systems, but perhaps the new radio advanced, so means release 18, 19, and then we will start talking about 6G. What we are expecting here is to achieve ground coverage, air coverage, and space coverage, currently presented as a two-dimensional coverage. I'm coming from network design, so I have designed many networks globally. So our job was to say, okay, give me your inputs, and then on a map, 2D map, I go through and I display the coverage, capacity, quality, parameter, and so forth. There we will achieve much more than that. So the target is to achieve this performance in a 3D, 3-dimension. And that is possible because you see how the system will evolve with the 5G and 6G, 5G already, let's not go too far, but even the LTE, if you have a proper design of beamforming, we can radiate and connect plenty of objects. So objects that would allow us to achieve not only coverage and use that as an access technique, but would allow us to integrate the system. We discussed about disaggregating the access, and that will also evolve not only on a terrestrial network. The access is going to be disaggregated all over the places, potentially. And you may see here that this will allow us to backhaul the communication and also front haul the communication using features connecting different type of objects, not necessarily, say, deployed on the ground, but on air, and the HAP UAV aircraft and on the space, using especially the LEO satellites that they range from 300 to 1500 kilometers. Now, when you put your hands in practice, because I've tried to consolidate these things, you may see that the technologies and the players and the business models are very fragmented. I tried to map on this table the most important available technologies from Wi-Fi, LoRa systems, and then of course the cellular terrestrial technology from narrowband and broadband type of machine communications up to the LTE release 14 and then 15. Of course, we talk about the new radio release 17, etc. It's very, 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 very fragmented. And so what we could, yeah, I hope if we had time now, I'd like to discuss with you how we see the possibility of integrating those systems, or how we could say what kind of technology could be exploited to really achieve a ubiquitous connectivity. And in my view, I think that could be done by first would require to go down in frequency, unless you don't want to complement some return to here. If you go down in frequency, then I think on the ground system, terrestrial system, down in frequency means playing with the 700 megahertz. Australia now it's 850, 900 megahertz, where we'll have I think a cell range of around maybe 30 kilometers. But still, if you have a footprint of 100 to 1,000 kilometers, you really have a challenge to integrate those elements. Therefore, I think we need to have in place something more that on air and on space will allow us to support a front hauling type of interfaces that has backhauling. And in addition, I think we need to have also an element of access to the services. Therefore, just in conclusion, I think the fundamental enabling technologies and capability, I think it's about spectrum availability. We need to go down in frequency, and then we need to have a technology which I agree with the earlier speaker, the Wi-Fi. If you look at Wi-Fi, even Wi-Fi 7, 6, I mean, the cell range is extremely small, because if you want to enjoy the bandwidth, you need to transmit at least at 160 megahertz band, and that won't allow you to have more than 50 meters range. Therefore, the deployment of those systems will be extremely local on campus, but it's far from, say, I think, achieving massive coverage. And then also the capability of having playing on unlicensed spectrum, which, by the way, will be also supported by the new radio in release 16. It is anyway limited. So I think spectrum is important. And when we go up in frequency, I think the only way for us to enjoy those services is to have different type of access points, because going up in frequency, the cell range, or anyway, the range of coverage, I've measured them, even in US, it is extremely limited. So you have a good coverage in line of sights up to maybe 700 meters, but then disappears when you go indoor. And then you cannot think of relaying all these things. So I think we need to introduce something that will be on air and on space. And here I think that the non-terrestrial networks will definitely make the difference, enable new business models, because there will be positive business cases, and practically integrating them, complementing them with terrestrial type of access network will allow us to achieve and say take the services or bring the services in areas where currently it's very hard to get and obtain any kind of signal. And the last thing, we need to find a way to bring the security controls and privacy. And I think here, the way forward, in my view, that's my personal view, we need to exploit the concept coming along with the 5G core. I'm not thinking of the core as an element, you may buy it, you may have it, extremely expensive. I'm thinking of the protocols that are coming with the 5G authentication and key agreement, or extending the protocol from the internet that is supported through the utilization of a USIM, which means any device. That could be this, that could be like that one, it could be my pen, anything could be connected and authenticated, authorized, and with also a large degree of accountability, because we need to trace anything in a unified way that is already specified, standardized in release 15 with the 5G core, or better, the stack of non-access stratum and the corresponding via entities. So thank you so much, Kanesh. I think that was pretty much. If you want to know more about these things, I play a lot with, I'm on LinkedIn. I like to play there. And there I am also sharing non-confidential material, which will be also this presentation available there. Okay, thank you.
Thank you, Prof. Thank you for the great insights. It was very valuable. Appreciate that. So yeah, let's have a quick 5 to 10 minutes Q&A sessions. If anyone on board have any questions from any speakers, please feel free to ask. Maybe I will start first, Professor David. I did realize on your last slide with reference to the architecture by 2030 was a quite interesting input here. There's one question that I'm still questioning myself, and maybe anyone could be able to give more info, which I'm lack of, in terms of the application platform in the architecture, right? So do we really have enough of applications in the market, in the industries, in the mobile operators or the hyperscalers that actually targets the low latency requirements, the mission critical control requirements? As I realize, the 5G was very much focused to the industrial manufacturing or agriculture or even petroleum, with the vast of IoT devices, connectors, and all so on and so forth. But when it comes to the consumer market, is 5G really tackling the consumer market? That's number one. I realized that when it comes to South Korea with 14 million of 5G subscribers, and it's my opinion, maybe I'm wrong, but I realized that only South Korea out of this world who have really focused into the consumer markets when it comes to the augmented reality applications, gaming, VR. They are the first guys who came out with the Pokemon many years back, right? So they have actually spending a lot of time into this application development, right? So how are there any other bigger operators or hyperscaler players are really focusing into the 5G, particularly on the low latency requirements, so on and so forth? Anyone can able to answer on that?
Well, I could start. Can you hear me? So basically, the reduction of latency, it is a fundamental enabler to all services. So that's an example of services to consumer, to home, and business to business type of applications. If you wanna deliver an experience like in Korea, South Korea, they're having, and I think that is the most important application for enhancing the mobile broadband experience. So I'm talking about the augmented reality, virtual reality, which can be applied to an unlimited number of use cases, from training, smart education, down to manufacturing, constructions, anything and everything. You need to reduce the latency. Otherwise, if you don't do that, it happens that you need to let all those capabilities in the device. Being the capability in the device becomes extremely expensive. So our target is, there is an example of a project that here in Australia has been submitted to the government to achieve what you say. achieve what you say means even in Australia start enjoying virtual augmented reality and create jobs, better experience. It is exactly what was presented earlier. You need to have a possibility of not only say make your interface more capable in terms of delivering good put. You need to reduce latency. In order to reduce latency, there is no other way than install the applications close to the device. That allows you two things. First is to excorporate, take all the expensive capability of the devices, including the brain of a robot, and move that on the edge cloud. That's the first thing. The second, so that cost of this device is accessible to anyone, not only rich people, but any student can have the possibility of buying these kind of devices, because the rendering capabilities as well as the interaction element will be in the cloud, the edge cloud, close to the edge. The other is the capability of reducing latency, and that will make it possible to have interactions between the individual and any service that could be here. So to me, this is a fundamental enabler that is the multi-access edge computing. And that requires, as I said, also a better way to transmit the signals at the radio interface, because we must reduce also the latency here. We need to increase the speed, and we need to be reliable through multi-connectivity. Otherwise, those services would be then somehow discontinuous. So that's basically what I think.
Yeah. Actually, let me react to it from different angle. And actually, exactly for the gaming and for the, let's say, interactive stuff, you need a low latency, and it's not only 5G who currently have is an enabler for this. But if you look to the, let's say, the infrastructure behind that, so this is exactly where all the challenge starts, because in principle, the backhaul and all the connectivity to cloud, for example, simply cost you a lot of latency and milliseconds, which you have to add to it. So in principle, every 200 kilometers adds 1 millisecond. So if you look where hyperscalers have a data centers, so simply the latency for hyperscalers is too high to really allow you something which is really interactive. So this is first thing. Second thing is that's why in overall ecosystem, you have this multi-purpose edge, which helps everyone to really get the latency down. And it has to be very close to applications. So let's assume it would have to be really around 200 kilometers maximum if you want to really go for something interactive and do a gaming on this. The last thing on the cloud part is that you need a high performance on that. So if you want to do gaming, most likely you would need some kind of GPU as a service in order to get the support rightly. So all those things are beyond 5G, but are, let's say, somehow influencing or let's say creating, you need a full ecosystem. So if you have an application, if you have a phone with a 5G, so you need to have the infrastructure to support the rest of the, let's say, end-to-end use case. That's why it's not so currently widespread. And it will come soon.
Thank you, Prof. Thank you, Mikhail. Any other questions on board?
Well, actually, I have one with regards to the, let's say, non-terrestrial communication, because everyone now see what Elon Musk is doing with regards to Starlink, and they are shooting thousands of satellites into LEO, but actually, I think they are not using 5G standards. So how do you see the interoperability in the future? Because I think that to create such a massive network which Elon Musk is currently creating is somehow, to create it once more, is somehow inefficient. So what is the future here?
I can give maybe a short answer about that. Actually, in today's market, it seems that 3GPP based satellite access is not the only candidate, because we have also seen in other domains, like for high-speed train, for example, in Europe, the European Space Agency is working also on both sides for 3GPP based NTN and non-3GPP based NTN. So classic satellite operators to serve high-speed trains, for example. One of the reasons is basically economic. Actually, the time to market for satellite for 3GPP based satellite is much longer, and existing technologies are already very mature and on market. So there will be a kind of transition period before 3GPP based satellite systems become more dominant, if we can say.
Okay, thank you.
Will also depend very much by the ecosystem. So if that initiative is supported by an ecosystem of players that will make it possible to integrate that technology all over the places. I'm thinking of the different form factors as new radio is now coming. Then I think there could be an element of scalability. I've seen that the police, there is public announcement in Australia now subscribe for those services from satellite Tesla. And that is about mission critical type of communication. Usually mission critical services such as voice do not require elements of latency rather than reliability. Thinking of push to talk, you say something, then over, then you don't need any special latency requirement or bandwidth. I think it's the reliability is definitely the fundamental requirements and availability of the service. And that's why it could be a market for this. Although I believe that we need to have a seamless integrations of communications, as is already painful today. For example, if you are having a device from a one vendor, you have a challenge to integrate your phone with your laptop, with anything that collects and store your data or information. So I think we should find a way now to speed up the adoption and deployment of new radio compatible technology, also because if you look at how the multi-access edge computing platform is now specified in 3GPP, which I do agree, it could be done independently also for 4G or other systems, but that approach integrates the stack with the stack of the device, introducing important elements of privacy preservation, security controls, and all the elements that practically allow them the massive adoption of trustworthy services and secure devices. So that's what I think.
All right. Any other
Extraordinary.
questions on board?
Maybe I have a question to the panelists, because there is a lot of discussion hype now on the ORAN, vRAN, Open RAN, and initiative test trials. Are you aware of systems already deployed where the system is truly multi-vendor and open and not coming from a single vendor, incumbent or not, by offering disaggregated architecture, but practically there is no interoperability between the, so let me go back to my slide. Yeah, yes, but then practically we have a hard time to integrate the, say the radio unit. I'm not thinking of active antennas because that is a completely different story, but let's think of even a 4G system where you have the remote radio unit and then you have the passive antennas. So do you have examples where you have integration and commercial utilization of a disaggregated system coming from multi-vendor? So you have different providers of the CU, DU, and the radio part. The second question is that horizontally. What about vertically? Are you also aware of data distributed unit would then support algorithm designed by a different vendor? Can you give me a concrete examples of commercial available solutions, not test and trials, something that is truly working, truly compliant to the regulators and meets the requirements of the consumers or anybody who does use those services?
Maybe I can share something.
Yes, Ganesh, please.
Like, for
I'm
example,
interested.
Rakuten, they have
Yeah.
used this RAN hardware from S-Pen and KMW Communications, and also NEC, Nokia, right? And their RAN software is based on LTO Star, and the core network is based on a Cisco for the 4G and the NEC into the 5G, and they use the Mavenir for the IMS. Or in terms of the cloud orchestration, they have used the Red Hat. And in terms of OSS, BSS, Netcracker, and InnoEye, and the hardware platform messaging, they're using the Quanta Cloud technologies, right? So, and then in terms, the other area, the other operator who have done such as cloud native is the Dish, right? Dish, they have used a Fujitsu as the RAN for the RAN hardware. And also for the software, they have used the Altio Star plus the Mavenir. And for the core network, they have used Nokia 5G core. And for the cloud orchestration, they have used VMware. And the network intelligence, they have used Sienna, Blue Planet. And also the OSS, BSS have done Matrix software. This is what I've known from these two different operators.
That applies in a really disaggregated cluster area, not like, say, this cluster is with that vendor, that cluster is with another vendor, and then you have say, inter-system handovers, or anyway, handovers to the core network with no capability of. So what I'm thinking here is the distributed unit would be from vendor A, CU unit from vendor B, and then remote, whatever you want to call this, depending on the type of antenna, from a different vendor still. Is that, can you confirm that on a single, say, communication? Assume my mobile is here, I'm making I go to internet, okay? So I go through this journey, you say that Rakuten provides an access point from vendor A, a distributed unit vendor B, and then vendor C for CU unit, and then it has also okay, core network's not a problem. Core network is I'm thinking of a horizontal, not cluster. So for example, here you could have like this part from vendor A, vendor B gives you this one, and overall you would have two vendors that would have compatibility through a communication which holds on the unified core network. So you confirm that you do have this type of interoperability horizontally through a single end-to-end communication channel. Kanesh?
I got to check
that,
Doctor. Really, I need to check, and I can come back to you on that.
Yeah, that would be nice. Yes, because I think many people are asking this, so everybody is interested too.
But is there any reason for this to not be a reality today?
I haven't. I mean, as I said, my view is very neutral. I do see that as an interesting implementation, and currently, based on my reading, there's still many challenges, and the only configurations I've seen under testing, not commercially deployed, is with some of the vendors that Kanesh mentioned, but I haven't read through that commercially, which means you have a grid of service which complies with the regulator and the customers paying for that. Is in place. That are my concern, because we tend to mix the architecture, which I have presented here on this slide, with so we tend to mix the capability of disaggregating the system, which has many benefits, but also drawbacks in terms of capacity, latency, and in practice, I think it doesn't make any sense when you look at the objective requirements to separate the CU and DU unless you are in the countryside. It's not viable. It makes no sense. No one would buy for it, would pay for it, because there is no business case, right? Because it does not support the requirement in terms of capacity, speed, latency, and so forth. So then when you have 90% of 95 or 98% of the cases where the CU is practically necessarily, for many, many reasons, but let's stick to the business case or site availability, to collocate these two parts, then the question to me is, why should I embark from a disaggregated configuration which increases my complexity into integrating the system, upgrading the features? Because if you look at the feature development, you may have a rapid enhancement of active antenna unit systems, where my active antenna could be capable of supporting FDD, TDD, and a variety of those spectrum in terms of aggregating large contiguous, distributed band and so forth, with the synchronization you're having at the distributed unit, where a part of the stack is incapable of supporting the MAC layer, because it's enabled to schedule the traffic that this particular antenna will now support, even providing me connectivity to drones, but I cannot schedule it because there is no coordination of enhancements at the physical layer with respect to the layer 2. And then can you imagine the layer 3, where, for example, the RRC has to be then resynchronized end to end as you upgrade the system with a new release, now maybe supporting, I'll give you an example, AFAMA, which is a way to authenticate and authorize internet traffic on top of the 5G system. How do you do this? Tell me. It comes from multiple vendors. Imagine you are a carrier, an operator, an incumbent that thinks of deploying this system. How would you approach to, say, upgrading your network and maintaining that?
Actually, my view about this is that in terms of capabilities and standards and protocols, there is a quite clear separation between the RAN and the core network. And any change in the RAN in terms of capacity of traffic, I mean, or supporting a new band or adding new antennas, this is something that should be transparent for the core network.
No, I'm thinking of aligning different features of the disaggregated RAN. I do agree that the core network has no problem. You upgrade that, that's finished. I'm not want to discuss about the connector. I'm thinking of the protocol stack, disaggregated protocol stack, which I tend to agree as values, as I presented on these slides, fantastic. I would like to understand from you is the multi-vendor type of ecosystem that if you think of upgrading or maintaining the system where you have different part of the radio access, forget about the core, the radio access may have different characteristics. So how would you orchestrate and make sure that the roadmaps of your maybe 1, 2, 3, okay, then you have the management 4, the machine learning pipeline is 5, security, maybe you give it to another 6. How do you think this ecosystem will smoothly evolve? Which goes beyond the technology itself and the architecture, which I think has value and is extremely important.
Could I add something there? Well, I'm just looking because I didn't present it in my slides, but I do know that Telefonica Argentina, that's I think they call it Movistar,
yes,
deployed an Open RAN based network in Argentina recently, and they used IBM as a systems integrator. They sourced technology from Altiostar, Red Hat, Quanta, Gigaterra, and Contron. So I think that's about about 5 different vendors. I'm not sure about the specifics in terms of CU, DU, and RU, as you asked.
Yeah, because that's the key part, how we synchronize the protocol stack of their core radio interface protocols. Yeah, if you have examples, I'd like to learn more.
There's one more.
Environment, if you could share offline and anything.
Okay, there's one more I can mention. Etisalat. Etisalat is a major Middle Eastern operator, and that they plan to deploy an Open RAN network in Afghanistan. So they're going to work with Parallel Wireless, Intel, and Supermicro. So these are the companies they're going to work with in terms of providing the different components of the Open RAN network in Argentina. Sorry, Afghanistan, not Argentina, Afghanistan. But I think that's something they plan to do. But like I mentioned earlier, they've who was it again? Telefonica in Argentina. They've actually deployed one, an Open RAN network in a city in Argentina, and they say it's an end-to-end deployment. So these are the two I in addition to the ones Kanish has mentioned, Dish and Rakuten Mobile. They're more upcoming, let me put it that way, because like in the UK, NEC is working to set up a test, well, it's a test bed for now, but they're planning to set up an Open RAN network in the northern part of Wales. But I think that's a plan for next year. They haven't specified the other partners they're working with, but that's an upcoming deployment.
I think we can stay in touch and share more information. I will see maybe Kanesh, you could organize other discussions on specifically the subjects the team has identified as relevant, or what do you think?
Sorry again, Prof. Would you mind to repeat again?
Yeah, you could. Sorry, you could organize other discussions, like on the key topics we have identified today.
Right.
It would be interesting. Yes. What do you think?
Yeah. Why not?
We could discuss every 15 days. I mean, really, on like today, you have brought together this group of experts. Yeah, we could continue, and if you identify topics like today, they were interesting subjects. Perhaps I think who watches us, or anyway, the industry, the many communities, they will be interested to understand more, and we could further discuss that.
For sure. I think that's a good
and also
idea.
Invite the people that have an offering, so we can really learn about. As I said, from my side, I am very neutral. We see as an approach, and really happy to learn more about that. Yes.
Would be nice if I can bring in Dish, Rakuten guys, the TIP parallel wireless.
Yeah, that would be nice.
Yeah, if you can get most of the new, I won't call it new, I mean, most of the Open RAN software vendors, I think it'll be nice. It'll be very good, because to get the perspective, parallel wireless, Altiostar, S-Pan, Mavenir, Benitel in Ireland, there's so many. Then of course you can have, I mean, Intel is there, IBM, and the rest are system integrators. So
to me, it is a key approach when you look at you see this slide. Yeah? I made this slide on purpose, because if you look at the rural areas, we do have an element of gain of a factor 10. You know what it means, a factor 10 in terms of investment and business case, where you have not many people to pay for the services. And yeah, you would need also support from governments. I'm thinking of Australia, for example. Then I'm not discussing the multi-vendor openness, doesn't matter. I'm thinking of achieving a disaggregated system that would allow us to aggregate centrally the traffic and come along with many access points or base stations. Yeah. And then we may think of going beyond that, where we could have a way to integrate these capabilities with other existing access and the technology and backhaul technologies, front-hauling technologies. But again, when you want to achieve then a seamless mobility, connectivity, or even the burden to the end user for he or she to buy those services, I do believe that we need to have a way of unifying the way you authenticate the end user, you authorize access to your services, as well as the accountability has to be unified. That's why I do believe that the 5G core and the stack, which is converging in all aspects, will stitch all those elements of access, which include, by the way, it would include also the Wi-Fi, because we have a fantastic interworking function which encapsulates all the non-access stratum and the user plane through the system to reach out a one single core network. Yeah, I don't know whether you share the same view. Or there are other solutions available. I'll be interested to learn.
So thank you for your valuable point, Prof. Doctor. And for sure, we need to actually have another separate session with the relevant people from the relevant radio hardware and the core as well, to give more insights on these new developments on the cloud native cloud and also the virtualization and as you said on the synchronous of orchestration and all that stuff. So so I believe this session was a valuable session. I think out of the 15 sessions that we had, this was the longest session ever.
Very interesting.
Fantastic brainstorm, and I really appreciate all the speakers to be here today. And hopefully, I'll try to arrange another session. Then I can bring all you guys together, and then we have another group of guys who can give a greater insights on the points that has been highlighted a few minutes ago. And I'm so grateful to all of you. Thank you so much. The video will be uploaded in a couple hours time on the YouTube channel. Thank you so much, guys. I appreciate it. Really appreciate it.
Thank you.
Thank you.
Thanks all. Take care.
Thank
Bye.
you, Ganesh,
Thank
for
you.
organizing it.
Bye-bye.
Have a great day.
Bye.
Bye.
I appreciate that.